Welcome back to Mishler Math, back on the air. We're going to talk about direct variation, inverse variation, combined variation, and joint variation. So let's see what that's all about. Remember direct variation? This is the back when chapter 1 we said y equals kx. Well, if k equals 1, then of course you had y equals x, and your graph looked like this, and a straight line, okay, like that. And it's just a straight line at a 45-degree angle because every one of your x values is exactly equal to every one of your y values. So no matter, your ordered pairs would be, 0, 0, 1, 1, 3, 3, -4, -4, etc. The x and y are always going to be exactly the same. Well, that was direct variation. Now remember, you also had things like y equals 5x, okay? And that would look kind of steeper. It would look like this, okay? And so either way, k is your constant of variation because k didn't change, okay? X and y changed, but k didn't change. That's the coefficient on the x, and it's also your constant of variation. In order to find k, we had to say we divide both sides by x, like that, cancel. K equals y over x. So if we're looking for k with direct variation, we'd say it's y over x. And once we find k, we plug it into here. We say y equals 5x. Let's say k equals 5. Y equals 5x, and there's your direct variation equation. Well, today we're going to talk about inverse variation. Inverse variation, just like it implies, it's inverse. So you have y equals k over x. So if you look at the graph of y equals k over x, well, because you got x in the denominator now, x cannot be equal to 0. And so your graph looks a whole lot different. It looks like kind of like this. Okay? And like this. And we'll do more of that in a couple minutes, but this is kind of what the graph looks like with y equals k over x. Now the k is still your constant of variation. Okay? It's still k because that's still a constant. Like you have y equals 1 over x, y equals 2 over x, y equals 4 over x, something like that. Your k is not going to change. That's going to stay the same. Your x and y vary, but k stays the same. So it's your constant of variation. So all you need to do to find k is multiply x times y, because look, if I multiply both sides of this equation by x, these two cancel, so I have k equals x times y. So there you go. I got k equals x times y. Now, where do I go from here? Well, let's suppose I say y varies inversely with x, and y equals 13.5 when x equals 4.5. So you gotta do two things. First, find k, your constant of variation, and write the equation for this relationship. Well, equation, not equations, just one equation, okay? So let's see how to do that. That's pretty simple. K equals x times y. So there, y is 13.5, x is 4.5. So 13.5 times 4.5 equals 60.75. So what that means is, when you write this as y equals k over x, you'd say y equals 60.75 over x. And sure enough, if we try this with try equation, we have 60.75, move this over a little bit more, 60.75 over x is 4.5, 4.5, enter. Sure enough, we have 13.5. Y is 13.5 when x is 4.5. Next thing we want to do is we want to find y when x equals 0.5, 1, 1.5, 2, and 2.5. Well, that sounds like a lot of work. Well, actually, no, it's not. Not with our graphing calculator. We haven't done much with the table, so I'm going to show you something about table. You know, this is your second button here is window. We'll hit second window because above that is table set. So we're going to put, first we're going to put the equation in here. Clear, clear, clear. We're going to put 60.75 over x. 60.75 over x. So that's our that's our equation, our inverse variation equation. So then we go to second table set, and tables start at 0. That little triangle in front of TBL, that means change in table. Remember, the delta means change in. So that means we're going to change the table every 0.5. So every time x changes by 0.5, I'm going to have a new value in the table. Say, what does that all mean? What do you mean by that? Watch. Second table. Table's right above graph. Notice when x equals 0, you got an error because there can't be a 0 in your denominator. So you're not going to have and also when you graph this thing, okay, get rid of my phone here. Also, when you graph this thing, you're not going to have any points at 0. So let's go on to the next one. When x equals 0.5, you have, remember your equation is y equals 60.75 over 0.5. Okay, x is 0.5. So what is your value in your table? 121.5. 121.5. Remember, divide by 1/2, that's 0.5, that's 1/2. You divide by 1/2 is the same as multiplying by 2. 60.75 times 2 is 121.5. So looking at your table, your first value is 121.5, okay? When x equals 0.5, y equals 121.5. So looking at your calculator again, for x equals 1, y equals 60.75. So 60.75. Kind of makes sense. You put 60.75 over 1, you get 60.75. When x equals 1.5, y equals 40.5. When x equals 2, y equals 30, and etc. So that's how you do a question like that. And you answer, you write out all the answers there, all the values. So it's pretty simple. So let's try another one here. And let me turn the page here. We're talking about, now we're going to talk about joint variation, okay? And I have no idea why it just did that, but this is a computer, so who knows why it does things. Okay, joint variation. You have another variable. So y equals k x Okay? Y equals kxz. You have another variable in there. So now the example is from geometry. So let's do a little geometry. We're going to build a rectangular prism. Some of you might remember this if you had a good geometry teacher. Like, of course, if you took Mishler Math Geometry. Now, this is the height, of course. And we're going to say the height is constant. The height is always 8 centimeters. Okay? But then we got the width and the length. Okay? Length and the width. Now, you may remember the volume is length times width times height. Well, in this case, since the height is fixed, it's not going to change, then the volume is 8 times length times width. Now, what we have here is this form, okay? We have this form. K is 8 in this case. Your length is x and your width is z. So, let's take a look and see what we have. Find the volume. If length equals 4 and the width equals 2. Come on now. Put the 4 here, the 2 here. 2 times 4 is 8 times 8 is 64 centimeters cubed. So that's how you find the volume in something like this. This is what we mean when we say joint variation. Okay? Then, combined variation. Combined variation. I'm just going to give you an example. Z varies jointly as x and y, and inversely as w. So write an equation. Let me stop there. Z equals 3 when x equals 3, y equals -2, and w equals -4. So, what are we going to do with all this? First, we're going to write an equation. Or, I should say, we're going to find k. So, with k, okay? So first we have to find k. What in the world do we do? Z varies jointly as x and y. So what we can say is Z equals k, x, and y, and then it inversely as w. When it says it varies inversely as w, we put the w on the bottom. Inverse means on the bottom. Jointly means we put the x and the y on the top. And the k, of course, goes on the top. Another way of writing that would be k times x, y over w. But because this is k over 1, we say k, x, y over w. If that's all confusing to you, hang in there with me a minute. Once we start working with the numbers, it might make more sense. So z equals 3. So if that's the case, let me change color here, see if we can work on this. Z is 3, okay? When x is 3, and y is -2, and w is -4. So 3 equals k times 3 times -2 over -4. Okay? Now, if I simplify this, I should be able to find k. K is just one variable, so let's try getting rid of the fraction first. -4, -4. Multiply both sides by -4. You get -12 equals k times 3 times negative 2. Okay? Well, negative 2 times 3 is negative 6. So negative 6k equals negative 12. Divide by negative 6, k equals 2. So now I can write this equation, okay, just like this, only with k, 2 instead of k. So z equals 2x, that's a 2 by the way, not a z, 2xy over w. Okay? So now it says find z when x equals 6, y equals 7, and w equals negative 4. Well, it's pretty simple now. We just fill in the blanks. Okay? We had z equals 2 times x, which is 6, times y, which is 7, all over w, which is negative 4, equals 12 times 7 is 84 over negative 4, which equals negative 21. Okay? So that's how you do problems like that. We'll talk about some more in class. Hopefully you understand a little bit by then.